Hello class, Mr. Stemple here. In this video, I am going to show you how to download and use the MD Solids software for the assignment. So we can just open up a new tab in my web browser here and go to www.mdsolids.com. See it right there. That'll pull up this website. You can go right over here to the left and download the software. Now when you download the software, it will open up, or it will download rather, a zip file that you have to download or have to open and then install. So install that zip file and it will put the MD Solids software on your computer. Once you get it installed, then you can open up the MD Solids software and it looks like this. This thing out of the way. It looks like this, and there's a lot of things on the MD Solids software that are very useful and very interesting to play around with. But today we're going to be talking specifically about this one over here, the section properties. So when you open up section properties, it allows you to create a cross section of a beam and then to test that beam. So I'm going to go here, do the simple box shape first. So the simple box shape is, of course, your hollow rectangular shape, as you can see right there. And I'm going to choose my standard sizes for it that I asked you to use. So a 15-inch base, 15. Make sure this is set to inches, 15-inch base. And then over here on the left, that's going to be 30 inches. And I want the size of the metal all the way around the box beam to be 1 inch. So that'll make it easy. So the entire base is 15 inches and each one of the sides is 1 inch. That means I've got 13 inches left on the inside. And if my height is 30 inches and each the top and the bottom are 1 inch, that means I've got 28 inches left on the inside up and down. It won't show you right away until you hit compute. The other thing that I want to make sure you set is down here under where it says elastic modulus. Remember, we calculated that modulus of elasticity. We're going to use steel. So I'm just going to go ahead and use this structural plate steel right here, which is 29 times 10 to the 6th power. In our calculations, we used 30 times 10 to the 6th power because it was easier to do the calculations on. This won't make that much of a difference. So I'm going to go ahead and compute that. And you'll see this screen opens up real fast over here. My box changes a little bit to be a little bit more in line with the dimensions that I chose. And I can see right here the moment of inertia for this box, or this box beam, is 9,968.667. So I don't need to have all the decimals in there. But if you look back in your notes, what you calculated should have been pretty similar to that. So I'm going to leave that with you. Go back and look at your notes and see how close you are to what we just calculated there. The next thing I'm going to show you how to do is to do an I-beam. So go back up here to flanged and choose I-shape. And look at that, my dimensions are already in there. Once again, a 15-inch base, 1 inch on the flange, 1 inch on the web, 28 inches between the top and the bottom flange, 29 million for the elastic modulus, and then compute. That opens up another window, and I get moment of inertia here, 8,139. Now I believe when we calculated that yet last week, we ended up with 8,140, which is pretty close. It's a rounding error, so don't worry about it. What I want you to do for your assignment this week is to calculate 3 different moments of inertia for 3 different beams. So all you got to do is change the dimensions here on this beam. So change the dimensions. Maybe I want to make this 12 inches, and maybe I want to make this, 25 inches, and then compute. There you go. There's my modulus of elasticity. My modulus of elasticity is the same. My moment of inertia has changed. So your POE assignment is to do that 3 times for the I-beam, 3 times for the box beam, and your IED assignment is to draw those 3 different beams in your notebook. There you go. That is how you use the MD Solids software. The next video will show you how to use the SkySieve software.